When we left off with this problem. Okay, we discovered that there was a whole bunch of butts that filled the pool, right? What was the purpose of why I showed you this particular problem? What were you supposed to glean?
That we don't have to understand what butt is.
Yes, you don't have to understand what a butt is. Okay? And that you don't have to have every single conversion factor memorized, because sometimes conversion factors are given to you in the problem. Okay? And so in this case, we gave you a definitional use of a unit that you never saw before, but we actually used it as the part of the problem. When you do dimensional analysis, the first thing that you have to identify is what? Whatever's given. Okay, that's important. Then you identify the unit that you want to go to. Okay, and then you have to know some conversion factors. Okay, there's a reference sheet on CHEM-111 that gives you lots and lots of conversion factors. I showed you that. That's probably something that you need to know and be familiar with. All right. Once you have a set of conversion factors, what I've asked you to do in some practice is there has to be some sort of relationship about how they fit together. And so I did for you, or I had you practice a conversion of time. So you knew some conversion factors, but what is the logic? Going from 1 to 1. Well, you know that if you start with a year, you can change years very easily into days, and days can be changed into hours, and hours can be changed into minutes, and minutes can be changed into seconds, because you know those relationships. Okay? But there are a whole bunch of other relationships that you should know, and that's what we're going to develop a strategy as you do homework, is developing those relationships. Really, what it comes down to in most of the relationships is this. You will have a unit, and there's only one thing you can convert it into. And if that's the only thing you can convert it into, that's the step you have to take. And then that will lead you to the next conversion, and the next conversion, and the next conversion. Some of these can get complicated, okay? And so some of you engaged in the tool that we use to help you think through the logic, and that's that map. Okay, we show you a simple map in this, and the map will just get more complex as we add more and more concepts that could be connected together. The one thing about chemistry and Chemistry 1 in particular is that all the concepts just about can be connected together. I've thought about it, and I know I could probably do it. I could make a one single question exam for the cumulative finals. That would cover just about every aspect of GChem 1. It would be nasty, but everything is so interrelated that we could conceivably come up with that. Okay, and so what I want you to do is learn individual pieces of information, but what's more important is how do they fit together? Because you're going to use the rationale of how they fit together to solve complex problems. All right. One thing about conversion factors that I did want you to understand is that they can be given lots of ways. They can say something is equal to something else. Mathematically, what we're going to do is we're going to place one of the conversion factors on the top and one of the conversion factors on the bottom, and we're going to multiply. Now, because a mile is the same distance as 5,280 feet, okay, it's the same length, it doesn't matter which one's on top and which one's on bottom. It makes the same statement. But mathematically, you place one of these on the bottom so that you can cancel out what you were given. So it can be written this way or it can be written that way. Depending upon what you need to cancel is when you're going to flip it. Okay? And so we can have lots and lots of different conversion factors. And so if by chance you're given a value in feet and you want to change it into miles, that's great. I know the relationship between feet and miles. That's one multiplication step. And I place it in this form because the feet will cancel out with that feet, leaving only miles. I've done half the math at that moment in time without even using a calculator. I have canceled the units. I've multiplied all the units out. Effectively, I've multiplied feet times miles divided by feet, leaving miles. And then later, you complete the mathematics by doing the numbers. Anything on top is multiply. Anything on the bottom is divide. And you would complete that concept. All right. The one issue about conversion, and this is what one of the things I wanted to identify, is you're going to know a lot of conversion factors that have a prefix and a base. So here, the K is a prefix, the C is a prefix, and those represented these numbers respectively, okay? But the base is meter. And so, traditionally, if you want to go from one metric unit to the next, what you have to go to is from kilometer into meters, and then a second multiplication step, meters into what in this case would be centimeters. And so from converting from one base unit or one unit that has a prefix to another unit that has a prefix, it would take 2 multiplication steps to complete that process. And so you can see in this, kilometers will cancel out, meters will cancel out, and left with centimeters because I have I'm given a certain amount of kilometers and I want to go to centimeters. And so conversion of the prefixes takes 2 multiplication steps. The other thing about conversion factors is this, that you can deal with more than one unit in a problem, but you have to deal with each unit by itself individually. And so here we're converting a certain number of pounds per hour into milligrams per second. And so in this case, it doesn't matter which one you start with, you just have to choose one. I chose pounds to do first. And so I took the pounds and I converted it into grams. The only thing, there are 2 ways I can convert pounds. I can convert pounds to ounces, or I can convert pounds to grams. And since I'm going to some sort of value in grams, that's why I choose the conversion factor of 1 pound to 453.6 grams. I changed grams into milligrams, and at this moment in time, I have gotten the unit that I want on the top. If I stopped the problem and didn't do the rest of it, I would have milligrams per hour. I don't want that. I now will change my hour into minutes, and then minutes into seconds, and then I will have milligrams per second as the unit. To do this calculation, this number times that, divided by this, divided by that, divided by that, will get us our answer. This is the calculator version. Do you enter in what's in your calculator? If you want to get it wrong on CHEM-111, you do. And how do you know it's wrong? You get a big red box, right? And it's like, wrong, right? It really tells you. How do you know when you get it right?
It's correct.
It's got this little tiny green, you're correct. It tells you, you're wrong. You're correct. I think there should be like, fireworks every time you get something right. That's so much more important. And then feeling like you've been defeated completely. And all the red boxes. So, you can convert more than one thing, okay? More than one unit, but you do them one at a time. The next item I want to, I'll come back to this in just a second. The next thing that I want you to do and to understand is that you're going to be using areas and volumes. More often volumes than areas, but you'll have areas in this particular calculation. If you have a unit that is cubed, that means effectively you have to deal with each one themselves. And so in this case, I have kilometers cubed. That means I have 3 kilometers. And if I want to convert kilometers into meters, I have to cancel out kilometers, making a 2, making a 1, have to do it 3 times. Okay? And so I have now 3 meters, and then I have a definition that 1 cubic meter is 1 times 10 to the 3rd liters. And so I can take 1, 2, 3 and cancel them out to calculate liters. And so you need to do things, you have to deal with, in terms of volumes, 3 times, and if you deal with areas, twice. Now, in the calculator, if you know how to use your calculator, you can put a value that is 1 times 10 to the 3rd cubed, okay? But you need to be careful about how you use your calculator. If I do this just to make sure I get it right, I would do this. I take this number, multiply that by that number once, twice, 3 times. You will always get it right going that direction. But if you actually put the cubic value in a parentheses with raised to the power with your calculator, that will mathematically work out correctly also. But you have to deal with all of the units, and sometimes you have to multiply it more than one time to make sure that is complete. Okay. In this case, cubic feet are being used, and so cubic feet 3 times here to represent converting cubic feet into cubic inches. Here, changing it from cubic inches into cubic centimeters. And then the last multiplication step is I can convert 1 centimeter to 1 milliliter because that is a definition that I know. And then the last multiplication step is a given value, a given conversion factor. And conversion factors that are given in problems normally, or a lot of the times, have a number divided by a number. That's a conversion factor. It can be flipped depending upon how you need to use it. In this case, I will use it with the milliliters on the bottom, and you'll end up with grams. Here's the problem. If you use CHEM-111, you want to make sure that you use every decimal place and do not round until you get to the end. If you do one step and round, and the next step and round, and the next step and round, it'll be wrong. Okay? So, placing the entire calculation in the calculator will be the only way CHEM-111 will think it's right. Okay? On the exam, we're a little bit less stringent on that, but CHEM-111 is very, very, very picky, so make sure that you put it all as one string of calculations so that your rounding only happens at the end. If you did stop at this point in time, you have to use the entire number in the calculator's memory to continue on. If you ever hit return, that is an issue with CHEM-111, not an issue with you actually calculating a unit value. It's looking for an exact number. Remember, anytime you start a problem, you look at the significant figure, and most of these are multiplying, dividing, so all conversion factors have infinite amount of significance, so you really look at what you start with, 1, 2, 3 significant figures, and so your problem needs to be in 3 significant figures. When you actually place it in CHEM-111, key here, anything that has to be valued that is cubed, you actually put the number that is cubed inside CHEM-111 for that to be correct. Okay. All right. So there's a lot of examples, but let's try a couple things. Because we don't know what we're doing until we actually do it. And sometimes even we don't know. All right. I think I had one of these, the last one on the last sheet, but I don't think we actually did it. So we're going to have it on maybe for YouTube. But there's a couple problems I'd like you to try with your partners to solve. Okay, another thing that is very helpful. If ever you need to go and work, get help on your homework. This is what my tutors and I expect. You should have the number of the problem that you're working on a piece of paper. And you should have your work. You shouldn't have to write down the problem because the problem is online. So don't write out the problem. But I do want you to write out your work. Okay? What did you set up? Just like these conversions, how did you set it up? It should be able to be read. So handwriting is a good thing. The penmanship will be great. And you should be able to show the flow of what you put on the piece of paper and the answer that you got. When you bring it to us and you're not getting it wrong on CHEM-111, we can take a look at that and see, this is the place that you needed to watch out for, if I have that. If you get to a place that you're not quite sure about, you should at least write down the things that you're given. What did you identify as a starting point? What did you identify as conversion factors? You can at least do those types of things. You might have identified the wrong thing. We can learn from that. But you should attempt the problem at least once because you get no points off for trying it once. Okay? You get full credit for trying it the second time. After that, if you are still wrong, it might be helpful to come get some help. Okay? So that you don't get lots and lots of points taken off for something that might have been very, very simple, simple to address. All right. Saying that my office hour today has to change to 4 p.m. So I do have office hours today, but it's going to be at 4 p.m. Okay. And so let's work on that first one. Changing miles per hour into meters per second. So, on 20th Street, you might be driving 50 miles per hour. You shouldn't because it's 35 miles an hour, but you know, I know what's happening. But, what would that be in scientific terms in meters per second? How fast would you actually be moving? Let me start you out. Oh, stop. That is so wrong. I lost my work too. Okay, I'm going to help you out again. Miles per hour times something. Oh, miles to feet. Okay. And then you want to go feet to inches? Inches to centimeters? And centimeters to meters? Oh! Stop. Stop. Please. Where did it go? I've lost it. Oh, you're kidding. Oh, there it is. Thank you. And then, stop. Come back. Thank you. Okay, and then now?
Hours and minutes.
Hours to minutes. Minutes to seconds, right? Okay. Done, really the math. I've done the math at this moment in time. Okay, now what we have to do is fill in conversion factors. 1 mile is 5,280 feet. Okay. What is the relationship between feet and inches? 12 what? 12 inches is 1 foot. Okay. This is a key right here. Conversion of a English length into a metric length. Okay, what is that one? 2.54 centimeters into 1 inch. That's defined. And then with prefix things, the 1 always goes with a prefix. And then 1 e to the negative per centimeter? 2. 1 hour is 60 minutes. 1 minute is 60 seconds. Okay. And does anybody have a calculator value? Okay, wait. 2.35, 22,
No, 22.35.
22.35? 2. Good. Now, okay, so that is a calculator value. And is that right? Sig figs is 22. Is that right? You need your new units. And what your units are? Meters per second. Yes.
We also read it 2.2 E would.
Yes. 2.2 e to the 1 meters per second is an equivalent number. And CHEM-111 will say yes, and we'll even say yes on the exam on that. And so if you get into the habit of doing one number, decimal something, e, that's perfectly fine. Because a lot of your answers will end up that way. Very rarely will we end up with something like 22. But it does happen. Okay? All right. The next question. Let me see what that says. Ooh, this is different. What is different about this one? We have squared stuff. Okay? All right. Here we go. Squared stuff. I'm going to go here. I'm going to go here. I'm going to do this. And, ooh, check this out. It looks kind of like problem number 2 on mine. So I'm going to work this problem. And I get this funny little map here. All right. The number is 6.39 e to the 8th f meters. Do you know what f stands for? Femto. Okay, and we're going to go to kilo or kilometers. Okay. What is this? Is this a length, area, volume, or mass? An area. So I come over here, and to use this tool, okay, watch what happens. I collect what unit I started with. Femtometer. Cubed. No, squared. And I have to convert it. The only thing I can convert that into directly is to meter squared. Okay? Do you see what happens in the chart down here? It actually sets the units in the right way. And then we want to end up in kilometers. Okay? And now what I do, now that I've set that up, do you know what you do now? You hit next. Okay, now what does that do? It gives me this thing. All right? And so, up at the top and up at the bottom, which one has the value of 1? The femtometers. Okay. And it's not just 1, it's 1 squared. So pull out your calculators. What is that? All right, 1. Good. All right. Now, what would be the value of the meter? What is femtometer? 1 e to the negative 15 squared. Okay. So what value is 1 e to the negative 15 squared? Do you know? Someone put that in the calculator? Negative e 1 e to the negative 30. We hope. Okay? And the 1 always goes to the 1 with a prefix, so 1 squared here is 1. Okay? And what is the value of kilometer? 1e to the 3, and if you square that, that becomes 1e to the what? 9? 6? Put it in the calculator. Put it in the calculator. What do you get? 1e to the 3 times 1e to the 3 is 1e to the 6. Okay? All right. Now, someone do some math for me. You don't ever forget this first number, 6.39 e to the 8th. And then what do? Times or divide? You multiply what number? 1 e to the negative 30. And then you do what? Divide by 1 e to the 6th. Okay, and what do you get? 6.39 e to the negative 2? 28. 28? Anybody agree?
Yeah.
All right, I'm trusting you. I'm trusting you right now because I'm gonna hit submit. This is the ultimate. I always hate this part. Don't you? Don't you? You're like, oh, it's gonna tell me right or wrong, and it says you're right. Now, do you know what's wrong? What's wrong here? I now have more points than some people in the class because I think I just made 5 points. So please work on your homework. All right, let's do the next one. Okay, back to assignment menu. Oh, check that out. The next one is just slightly more complex. Okay, and so this one is just going to give you it's a multiple choice. You got 5 chances to get it right, so you can get this one right. Right? No, you can't. There are 6 choices. That's not good. So what in the world do I do with this? You pray. That's a good thing. Okay. What strategy do I need to look at when I read this problem? What are you trying to find in this problem? Mass over volume. And what is mass over volume called? A density. You got to find a density. Okay? And so when you look at that problem, I'm going to throw over here. I'm going to, I can just do that. I can just use this page because it's nice and clean now. You have to have a mass over a volume. And so we decided that the mass was what in this problem? What you read on your page. It's ounces, right? And the value is ounces, right? Which is kind of a weird thing because ounces is not very straightforward because there's also a volume of ounces. So this is a weight ounces over the volume that we discovered was what? Gallons. What is the unit that we want to get to? Grams over milliliter. How did I know I wanted a gram over milliliter? You're given it in the problem. All of the reference material is in grams per milliliter, so that we have to take whatever we're given and change it to the things that we're going to compare it to. Okay? Stop. Okay. Well, this is just wonderful. Ounces over 5.24 e to the minus 3 gallons. Okay, what can I change ounces into? Pounds. Okay, 1 pound is how many ounces? 16. If you didn't know that, how would you find this? There's lots of ways, but what's the best way? You could Google it. That's a really convenient way to do it. But if you want to use the right number, you should use the CHEM-111 reference tool. Okay, there's a sheet with these, and so Googling will give you a correct answer. Googling will give you a number that can be used mathematically. And what you will do is you'll probably calculate something correctly, but you'll get an answer that is within 1% of the answer, because Google rounded it a little bit differently than CHEM-111. On the exam, it would be perfectly fine, but on CHEM-111, they want you a specific way, and it is not forgiving. Now, what can you change pounds into? Grams. And so, in terms of pounds and grams, and remember we want grams per milliliter, in 1 pound, how many grams are there? 453.6. All right, at this point in time, ounces are gone, pounds are gone. I now have grams per gallon. Not what I want. Okay? How would you like to take care of the gallons? What do you want to change them into? Quarts is a good way. Not the only way. Okay. So, gallons into quarts. Okay. All right, we had ounces to gallons, ounces to pounds, and pounds to grams. Now, gallons to quarts, and then we change quarts to what? Liters, and then we change liters into milliliters. Okay. 16 ounces, 453.6 to 1. 1 gallon is 4 quarts. Here's the key one between English and metric. How many quarts? 1.057 into 1 liter. And if I place 1 in front of the one that has the prefix, liters is 1e to the negative 3. I now have ounces out, pounds out, leaving grams. I have gallons gone, quarts gone, liters gone, and mils. I now have grams over mil. And then I had a number that was 0.663 over 5.24 e to the minus 3. That is the ugliest 3 I've ever seen. All right. In this case, 0.663 divided by 5.24 e to the minus 3 divided by 16 times 453.6 divided by 4 times 1.057 times 1e to the minus 3 gives you a value of what? What is it? 0.9, what is it? 48 grams per mil. Okay, so what is the compound? Cyclohexanol. And so all of that work, so I can go back and do that, okay, and then hit submit. You guys did more correct work. I love it. Okay, and so some of the conversions will use the conversion map. Some of them don't. Okay, one thing that you do not have for the exam is the conversion map. So why do we give you that tool? We want you to build those relationships. What can be converted to what? Most of the time when you look at the map, you can only convert to one thing. Okay? Gallons you can convert to a couple things. Okay? But there's one or two things in which it can go. And so everything is built in relationship that way. Okay? So, sample problem here. All right? Oh, lots of words. The volume of an irregularly shaped solid can be determined from the volume of water it displaces. Okay? So, you put some water inside a graduated cylinder. Measure its volume. You throw something in it. The water is going to raise. Eureka. We discovered that we can find volume that way. When a small piece of this mineral or of lead is submerged in water, okay, when the graduated cylinder started at 19.9, the volume increased to 24.5. What is the volume in cubic centimeters and in liters? Well, if it went up to 24.5 and it started at 19.9, the volume is 4.6 milliliters. Now, we know one conversion factor, that 1 milliliter was defined as 1 centimeter, and so we just changed the unit. But mathematically, we would show it this way. We'd actually do a multiplication step in which the milliliters cancel out to give you centimeters. You could also do this. You can change milliliters into liters because we know the relationship. 1 milliliter is 1 times e to the minus 3 liters, and we can answer the question in liters. Okay? And so, we were given units of milliliters, and then we wanted centimeter and liters in two separate experiments. Sample problem 2. Lithium. Soft gray solid that has a lowest density of any metal. A slab of it weighs a certain amount in milligrams and has the size, oh, this is just mean. We give you millimeters times millimeters times millimeters. What is its density? Okay? Did I give you a volume directly? No, but can you calculate a volume? Yes, you take all of the links and you multiply them together and you will get a number of length, a number of volume in cubic millimeters. We don't want cubic millimeters. What do we want? Cubic centimeters, so we change that into cubic centimeters, which is the volume. And then we can change the mass into grams. And what is the unit I want? Grams over cubic centimeter. The reason why we change millimeters cubed and milligrams into grams and cubic centimeters is because we're looking for that particular unit because the problem defined it. And so, yes?
Right. So would you go from millimeters to the centimeters first, and then you times them all together?
You can do either. Mathematically, it is equivalent, but what you need to do is get to the volume in whatever unit, but get that unit, that volume unit into cubic centimeters. So, there are multiple ways to calculate things. Here's what we're going to grade you for on the exam. We're not going to grade you particularly if there's two paths. You won't get one right and one wrong. What we want you to do is justify what you did. You need to show every unit canceling out and every multiplication step to get to your answer. As long as you can justify what you did, even if there's two paths, you'll get full credit. We just want you to understand the relationships in the way that you understand to get to the final product. Most of the time there's one path, but every so often there will be 2 or 3 different paths to get to the right answer. Whichever one you choose, you just need to show every piece of work to get you there. And I will accept that to being right. Okay. This one's interesting. All right. As you read this, what is your starting unit for this? It is, the starting unit in this is kilometer. Because the length of the cable is what is driving this so long. Okay? A conversion factor in this, there's several. Here, pounds per meter, or pounds per meter. That's a conversion factor that you'll use. Do you see another conversion factor in this? We want the total mass in kilograms. That's the final unit. Okay? So this is where I want to end up. This is where I start. Any other conversion factors? Strands per cable. Here's a conversion factor. There are 6 strands in one cable. Okay? And so, in this case, you start off with a unit of kilometer. You want to get to kilogram. You're going to have to find out how long the fiber is. Okay? But each fiber, you need 6 of them to make a cable, and so you have to make a calculation that there are multiple fibers in the cable. You can only change it into pounds of cable because that's what's happening here because of that conversion factor. And then once you have pounds, the next conversion factor is one that you should have memorized, is how many pounds per kilogram there are. And you can work it that way. Here's all the work. Individual steps. Down here is how I would rather you write it and enter it into the CHEM-111 because this will prevent you from rounding, stopping in the middle, and writing a number down. If you ever have to stop in the middle, you have to write every single number in the calculator so that it makes sure you get it correct.